So now let's combine everything we learned to try and solve a more complicated equation. This is a pretty complicated one. We've got many steps here. We've got brackets, we've got variables on both sides. So there's a lot of things that we need to unpack here. In the end, what we want is to isolate that variable x. We want x by itself on this side and just one number on this side. So we have a couple of options. We can either do what we did originally, which is find out what the last thing we would do is, according to BEDMAS, and get rid of that first. But I think in this case, what would work better is if we got rid of the brackets. So let's get rid of these brackets. And the way we do that is by multiplying -2 over 3, don't forget the negative sign, -2 over 3, with both terms in the brackets. All right, so this part of the equation doesn't change. Or the left-hand side stays the same, 1 plus 2x. We haven't changed that. Equals, the 3 doesn't change. But now -2 over 3 we're multiplying by x, and -2 over 3 we're multiplying by 6. So multiply -2 over 3 times x. Well, that's easy. -2 over 3 times x is -2 over 3x. And then multiply -2 over 3 times 6. -2 over 3 times 6 becomes -4. So now our equation is 1 plus 2x equals 3 minus 2 over 3x minus 4. So now I'm going to do what I said I would do before, which is isolate the variable. First, I need to move the variables to one side. So we've got -2 over 3x on this side. We have 2x on this side. Let's move this over here. And the way we move it over here is if we add 2 over 3x, because then they cancel out. -2 over 3x and plus 2 over 3x cancel out. And if I do that on both sides of the equation, then my equation looks like this. 1, it's just 1, because there's no x here, so we don't need to change that, plus 2x plus 2 over 3x. 2 and 2 over 3, when we add them together, we get 8 over 3x. So we're just adding the like terms, like we did with polynomials. So that's this side of the equation. Then on this side of the equation, this and that, these two numbers, canceled out. Cancel each other out. You add and you subtract the same amount, you get 0, you cancel out. They're no longer there. So everything else is still there. 3 is there, -5 is there, and that's what our equation looks like. Well, 3 minus 4, we can combine those terms too. 3 minus 4 is -1. So now our equation becomes 1 plus 8 over 3x equals -1. Okay, we're going to have to go to a new page, so we're going to have to erase all this. I'm just going to take this last equation and move it to the very top cell. 1 plus 8 over 3x equals -1. Right? What do we need to do now? We need to isolate the x. So we have a multiplication. We multiply that by 8 over 3. And then we add 1 to it. Or you can think of it as multiplying by 8, dividing by 3, and adding 1 to it. Either way, the last thing we're doing is adding 1. That's what we get rid of. So we are going to subtract 1 from both sides. Subtract 1 from here, subtract 1 from here. You'll notice each time we do one of these things, when we do something to both sides of the equation, we're simplifying our equation so that there are fewer operations. So we take away 1 from both sides. 1 minus 1 is 0, so you're left with 8 over 3x. And then -1 minus 1 is -2. And we saw how to solve a question like this early on when we multiplied by 3 and got rid of the 3, and then we divided by 8 and we got rid of the 8. You can actually do it in one step. When you have a fraction multiplied by a variable, multiply by the reciprocal of the fraction, which means if you've got 8 over 3 times x, multiply by 3 and then divide by 8. 3 over 8. You can do that in 2 steps. Here, in 1 step or 2 steps. Here I'm showing you how to do it in 2 steps, but you could do it in 1. But if you were going to do it in 2 steps, do it the longer way. Multiply both sides by 3, cancel out the 3 first. You get 8x equals -6, because -2 times 3 is -6. And then let's get rid of that 8 dividing both sides by 8. And then you get your final answer, x is equal to negative 3 over 4. And finally, we got the answer to our equation. That should be the only answer to the equation. Once again, I'll leave it up to you to prove that that is the answer by replacing it in the original equation.